So next time you pass a massive 18-wheeler on the highway, I actually want you to try a little thought experiment.
Oh, okay.
Yeah, I want you to not look at it as a vehicle.
Yeah.
Look at it as this rolling spreadsheet of extreme variable costs.
Right. I like that.
Because a single delivery truck idling in traffic
Oh.
is really just the highly visible, incredibly vulnerable tip of a massive global system. I mean, we see them everywhere, right?
Oh, constantly.
They're just the background noise of modern life.
Yeah.
But how much do you actually know about the incredibly complex, highly calculated network that got that specific truck to that specific spot at that exact time?
Yeah, and the reality is most of us don't give it a second thought. I mean, we simply expect the package to materialize on our doorstep.
Right.
We expect the grocery store shelves to be, fully stocked with fresh produce in the dead of winter. But the physical supply chain is a really fragile choreography.
Yeah.
And it fundamentally relies on rubber meeting the road.
And that is exactly our mission today. We are taking a deep dive into the source material, specifically focusing on Module 6, Section B, which is all about road transportation characteristics.
It's a huge topic.
It really is. We are going to unpack the literal physical foundation of the supply chain. We're looking at the roads themselves, the highly specialized vehicles that navigate them, the fascinating operational structures like drayage and multi-stop routing, and the counterintuitive economics behind how it all runs.
Yeah, and the massive hurdles threatening to stall the entire industry, which is a big deal right now.
Exactly. Okay, let's unpack this.
Yeah.
Because by the end of this deep dive, you are going to be the most informed person in the room about how the physical world actually gets its goods.
And it is entirely worth your time to understand this because road transport holds one massive, unbeatable advantage over literally every other way we move things on this planet.
Which is?
It is the only mode of transport that truly offers door-to-door delivery.
Yeah.
I mean, a massive cargo ship cannot pull up to your local pharmacy, right? A freight train cannot drop a pallet of goods at a suburban driveway. Airplanes require miles of concrete runway.
Yeah, so even if it crosses an ocean, it eventually has to get on a truck.
Precisely. Even if a product crosses the ocean on a freighter or, the country on a rail car, a road vehicle is almost always utilized for that vital first mile and that crucial final mile. It is the undeniable connective tissue of the global economy.
Which means we really have to start from the ground up. Literally, I mean, you can't understand the trucks without understanding the surface they drive on.
Right, the infrastructure.
Yeah. While I generally picture roads as just endless ribbons of smooth asphalt, the source material points out that infrastructure varies wildly depending on your geography. And the way those roads are funded, maintained, whether that's through fuel taxes, license fees, bridge tolls, that directly impacts the shelf price of every single thing you buy.
It absolutely does. You have to remember, transportation carriers operate on notoriously thin profit margins.
Oh, really thin.
So if a particular highway route levies a heavy bridge toll, the carrier's routing software has to account for that. They will routinely route a driver on a longer, slower path just to bypass a toll booth.
Wait, really? Just to avoid a toll?
Oh, yeah. They are actively trading extra diesel fuel and driver time for a lower infrastructure fee. It's a constant balancing act.
That's wild. But beyond the taxes, the physical quality of the infrastructure itself dictates the fundamental efficiency of moving freight at all. The sources highlight some wildly extreme examples of this.
Like the seasonal roads.
Yes, the seasonal routes that dictate the entire economic rhythm of a region. We're talking about ice roads in extreme northern latitudes. I mean, these routes cross frozen lakes and marshy tundra, and they only exist in the dead of winter. It sounds like a video game level.
It really does. And the logistics required to utilize an ice road are fascinating. Entire communities and heavy industries like remote mining operations, they have to stockpile a full year's worth of heavy equipment and supplies.
Or they only have a tiny window, right?
Exactly. They only have a 6 to 8 week window where the ice is actually thick enough to support the weight of a loaded semi-truck. Once the spring thaw hits, that road just reverts to impassable swampland.
That is incredibly stressful. The text also mentions tidal roads in coastal areas that just vanish under the ocean. They're only accessible during low tide.
Right.
And then there are wet roads. These are thoroughfares designed to literally be underwater, fording shallow rivers or flooded areas. The text notes that navigating these requires specialized vehicles equipped with engine snorkels.
Snorkels on a truck.
Yeah. The snorkel raises the air intake above the roofline to prevent the engine from sucking in water and hydrolocking. You're basically turning a delivery truck into a submarine.
Which is amazing, but while engine snorkels highlight the extreme adaptability required by road transport, we only need to look at everyday infrastructure to see how road quality acts as a massive friction point.
Yeah, for sure.
The source notes a stark contrast in global paving statistics. For instance, in the United States, roughly 67% of roads are paved. The remaining third is just dirt or gravel.
A third. Wow.
Compare that to a denser, more compact nation like Germany, where 100% of the roads are paved.
Okay, so when a third of a country's roads are unpaved, you're inherently adding time to the delivery.
Right.
You're increasing the violent vibration and wear and tear on the vehicle's suspension, and you're drastically raising the risk of damage to the goods just bouncing around inside the trailer.
Exactly. A poorly maintained road is essentially a physical tax on the economy. Every pothole, every detour, it adds fuel and maintenance costs. But natural geography and poor maintenance aren't the only friction points. Governments frequently engineer human-made obstacles.
Right, through strict regulations.
Yes, often to protect their environments.
The Switzerland rule is a perfect example of this engineered friction. Switzerland has a strict law prohibiting trucks weighing over 28 metric tons from traveling more than 10 kilometers into the country.
And 10 kilometers is nothing.
It's only about 6 miles. So to get heavy freight across the country, those massive trucks literally have to drive up onto specialized flatbed railroad cars. They use the rail system to basically piggyback through the Alps.
And those regulatory limits are intentional friction. Switzerland is forcing a multimodal transportation approach to reduce road wear and lower diesel emissions in a highly delicate alpine ecosystem.
Makes sense for the environment.
It does. It protects the mountains. But for the logistics manager, it introduces a massive operational hurdle they have to plan, coordinate, and obviously pay for.
Those regulatory limits are intentional, but the friction that actually drives people crazy is the unintentional kind. Traffic congestion.
Oh, yeah.
Because, I'll be honest, when I'm sitting in a massive traffic jam, my blood pressure's just spiking. I always assume there must be a terrible accident up ahead blocking the lanes.
I think we all do.
But the road congestion data in the source material completely disproves that assumption. I mean, I always assume traffic jams are caused by accidents, but the data says otherwise, right?
It absolutely does. The Federal Highway Administration data breaks road congestion down into a pie chart that always catches people off guard.
Right.
Traffic incidents like collisions or stalled vehicles, they only account for 25% of congestion. Bad weather causes 15%. Work zones and construction account for 10%.
Leaving the biggest slice of the pie, a massive 40% of all traffic congestion, simply due to bottlenecks.
It is a pure infrastructure capacity issue. The sheer volume of vehicles on the road exceeds the physical space designed to hold them.
Right, just too many cars, too little road.
Exactly. And when a delivery truck sits idling in a bottleneck, it is burning expensive diesel, paying a driver an hourly wage to go literally nowhere, and pushing back the delivery window of the goods. Every minute spent in a bottleneck is a cost eventually passed on to you, the consumer.
Okay, so that covers the physical ground we are driving on. Let's look at the vehicles themselves. Because the roads vary so wildly in quality and regulation across the globe, the vehicles driving on them have evolved to be incredibly specialized.
Highly specialized, yeah.
The sources break down two main configurations. You've got your single-unit vehicles, which covers everything from, a bicycle courier in a dense city center to a standard delivery van. And then you have the truck-trailer combinations.
And the variations within those truck-trailer combinations are vast. I mean, they're driven entirely by the physical dimensions of the cargo and the constraints of local laws.
The international variations are what get me. Australia utilizes what they call road trains.
Those are incredible.
They really are. Because they have these massive, flat, unpopulated stretches of the outback, Australia actually permits a single truck cab to pull 3 or more trailers at a time. It visually resembles a train just rolling down the asphalt.
Yeah, whereas the European Union takes the complete opposite approach. To protect their older, highly compact urban infrastructure, EU regulations tightly restrict vehicle length, and they cap the gross vehicle weight at 40 metric tons.
An entirely different environment.
Exactly. But regardless of the length of the region, if we connect this to the bigger picture, the true power of road transport lies in the trailer.
How so?
Well, a pipeline is incredibly efficient, but it can only move liquids or gases. A rail hopper only moves bulk commodities. A truck cab, however, can swap its trailer to haul absolutely anything. It gives unmatched flexibility.
Right. And the source breaks down the mechanics of these specialized trailers. You have dry vans, which are just the standard enclosed metal boxes protecting normal freight from the weather.
Right.
You have flatbeds used for heavy, odd-shaped loads like construction lumber or steel beams that need to be loaded from the side with a forklift. And then you have lowboys, or step decks.
Oh, lowboys are a brilliant piece of engineering. They are essentially flatbeds that drop their deck incredibly low to the ground right between the axles.
And they use those to haul super tall items, right? Like construction cranes or massive industrial generators.
Yeah.
Because dropping the deck lowers the center of gravity of these massive objects. That prevents the truck from tipping over on a curved highway off-ramp. And I guess it ensures the load can actually clear the height restrictions of highway overpasses.
Exactly. We also have to mention reefers.
Ah, yeah.
The temperature-controlled, refrigerated trailers. I mean, modern global diet relies entirely on reefers. They move our fresh produce, dairy, meat, and vital pharmaceuticals.
Right.
And they achieve this by carrying their own independent diesel generator mounted right to the front of the trailer. It just runs continuously to power the refrigeration unit.
Which means they're burning fuel to move the truck and then burning a second tank of fuel just to keep the box cold.
Exactly. Double the fuel consumption.
Man. And then there is the skeletal trailer, also known as a container chassis.
Very important.
It really is, and it's so simple. It is just a bare metal frame with wheels. A massive loaded shipping container gets lifted right off an ocean freighter and locked directly onto this skeletal frame. So instantly, an ocean container becomes a highway trailer.
Yeah, the skeletal trailer is the critical adapter cable of the global supply chain. It physically links the maritime ocean network directly to the domestic road network, which is what makes intermodal shipping possible.
So once we understand the vehicles, we really need to examine how businesses actually utilize them. Because if you manufacture, say, custom office chairs, you don't necessarily want to purchase and maintain a whole fleet of 18-wheelers.
No. Definitely not.
You need to buy space on someone else's truck. And the text details this complex choreography for how this space is bought and sold, starting with less than truckload shipping, or LTL.
Right. LTL is utilized when a company's shipment is too big for a parcel carrier like the post office, but not large enough to fill an entire trailer.
Okay.
And the logistical dance required to make LTL efficient is just staggering. Let's trace your palette of office chairs, right?
Let's do it.
A local pickup vehicle visits your manufacturing dock, loads the chairs, and drives them to a local break bulk terminal.
Wait, so the goods do not go straight to the customer?
No, not at all. At the break bulk terminal, the chairs are unloaded, sorted on a massive warehouse floor, and combined with entirely different freight. Maybe pallets of dog food or car parts that just happen to be heading in the same geographic direction.
Oh.
Then all of that is loaded together into a larger line haul trailer.
And then that line haul truck drives across the country, I assume, to a second break bulk terminal near the destination city.
Exactly.
And then the trailer's unloaded again, sorted again, and your chairs are placed onto a final local delivery truck that actually completes the route to the customer. So LTL shipping basically functions exactly like taking a commercial flight with connecting layovers.
That's a great way to think about it.
Right. You board a small regional jet, which is the local pickup. You fly to a massive hub like Atlanta, that's the break bulk terminal. You get off, mix with different passengers, and board a larger cross-country plane, the line haul truck. You land at another hub, sort out again, and take a final small flight to your destination.
Exactly. It takes longer. And the cargo is physically handled multiple times, which drastically increases the risk of damage or loss. But sharing the space makes it significantly cheaper than chartering a private plane.
And truckload shipping, or TL, is that private charter flight. The truck picks up your goods, seals the trailer doors, and drives directly to the destination. There are no break bulk stops, no sorting. It is faster and more secure, but you pay for the entire volume of the trailer, regardless of whether it is full to the roof or half empty.
Right. And the personnel driving these trucks, they fall into two distinct categories in the source material.
Okay.
You have company drivers who are standard employees of a trucking firm. They drive a truck owned by the corporation. They're paid a set wage or a per mile rate, and the company handles the vehicle maintenance, the insurance, and all the overhead.
Okay, and the other category is the owner-operators. These are independent contractors and small business owners who actually purchase and own their own semi-truck.
Yes.
So they take on all the financial risk, the monthly truck payments, the catastrophic repair bills, the volatile fuel costs. but they gain the freedom to choose their own loads and negotiate their own freight rates.
Which brings us to the operational reality of the road market structure. The text outlines two highly specific operational movements that define the industry: drayage and multi-stop routes.
Right. Drayage is fascinating because it's the shortest, but often the most frustrating leg of the entire supply chain.
It really is.
Drayage is the specialized, hyper-short distance movement of a shipping container. It usually involves picking up a container from a seaport using one of those skeletal trailers and driving it just a few miles to a local railhead for cross-country transit, or maybe to a nearby warehouse to be unpacked.
Yeah, and drayage drivers might only drive 20 miles a day, but they spend hours navigating the severe bottlenecks and bureaucratic red tape of port terminal gates.
Just sitting in line.
Exactly.
Yeah.
Compare that to multi-stop routes, which represent the classic traveling salesman problem.
Oh, right.
A truck leaves a distribution center fully loaded and has to make 10 different deliveries to 10 different retail stores. The operational challenge there is creating a routing algorithm that minimizes empty miles and ensures the heaviest items are unloaded first without forcing the driver to cross their own path.
It sounds like a massive puzzle.
Yeah.
And the choice between using an LTL connecting flight, a TL direct charter, or a parcel service is entirely dictated by the unique cost structure of the trucking industry. And this is where I actually have to challenge the source text a little bit.
Oh, why is that?
Because the phrasing seems completely counterintuitive.
Okay.
The text states that the road transport industry has, quote, relatively low fixed costs. But wait, a brand new semi-truck can cost over $150,000.
Sure can.
And the specialized trailers are tens of thousands more. So how can the sources say road transport has relatively low fixed costs? Calling that a low fixed cost feels absurd.
Well, I mean, it feels absurd until you view it through the lens of relative economics.
Okay, explain.
Compare a trucking firm to a railroad company. To move freight, a railroad must purchase the real estate, lay thousands of miles of steel tracks, engineer the bridges, build the electronic signal systems, construct massive rail yards, and then perpetually maintain all of that private infrastructure.
You're right, that's huge.
Or a pipeline company. They have to buy the right-of-way and weld hundreds of miles of high-pressure steel pipe. Those represent astronomical, multi-billion-dollar fixed costs.
I see. A trucking company doesn't build the highway. The taxpayers build the highway.
Exactly.
The trucking company simply uses public roads. Therefore, their fixed costs, like buying the truck cab, paying the insurance premium, perhaps leasing a break bulk terminal, that only makes up about 10 to 30% of their total operational costs.
Right.
So the barrier to entry for a trucking startup is remarkably low compared to starting a new railroad.
Right, but the severe trade-off is that a trucking company's variable costs are punishingly high.
Because they're on those public roads.
Yes. Because they utilize public roads, they are constantly bleeding cash for fuel taxes, bridge tolls, rapid vehicle wear and tear, and of course, hourly labor. The more miles they drive, the more they pay, instantaneously.
And the text highlights just how extreme these variable costs get. For an owner-operator, fuel costs, just the diesel, consumes a massive 23.4% of their total revenue.
It's staggering.
And if they were pulling a reefer, running that secondary diesel motor to keep the cargo frozen, that variable cost jumps to 28.3% of their revenue going straight into the fuel tanks.
And because the industry operates on such a high variable cost structure, they simply cannot absorb economic shocks.
No buffer.
Exactly. When global diesel prices spike, carriers are forced to immediately pass that cost on to the shipper through fuel surcharges, which, as you guessed, eventually hits the consumer's wallet.
Right. Now, obviously, road transport gives us unmatched door-to-door accessibility. And the pneumatic rubber tires provide a much smoother ride than a clunky train car, meaning less damage to fragile electronics or glass. But the environmental cost of this system is brutal.
Yeah, there's no way around it.
The text is unambiguous here. In terms of air pollutant emissions, trucking is 3.5 times less efficient than other forms of land transport, like rail. It produces the highest greenhouse gas emissions of all transport modes relative to the volume of freight moved.
It's a huge issue. We have engineered this incredibly flexible door-to-door system to cater to our demand for rapid delivery. But that system relies on a highly fragile set of human and physical resources, and currently those resources are being stretched to the breaking point.
And here's where it gets really interesting.
Yeah.
The final segment of our source material dives into the massive hurdles threatening to stall the road transport industry today. The most glaring issue, the people behind the wheel. the industry is facing a catastrophic labor crisis.
A very serious one.
The American Trucking Association estimated a shortage of 80,000 drivers in the U.S. alone in 2021. And if current trends hold, they project that shortage to hit 160,000 drivers by 2030.
160,000 empty trucks.
Yeah.
It is a perfect storm of demographic and regulatory factors. The current workforce is rapidly aging toward retirement, and younger generations are avoiding the field.
Why is that?
Well, the working conditions are grueling, often requiring drivers to live in their cabs away from home for weeks. Furthermore, federal governments mandate strict hours of service rules.
Oh, right.
These laws dictate precisely how many hours a human being can drive before they are legally forced to pull over and sleep. It absolutely protects public safety, but it severely limits a driver's earning potential.
Because if they're not driving, they're not earning.
Exactly. Add in the rigorous, expensive process of obtaining a commercial driver's license, and the barrier to entry for labor is just really high.
But the text also points out that it's not just a shortage of people. It's a shortage of the physical equipment, specifically those skeletal trailers we discussed earlier.
The chassis shortage.
Yeah, a shortage of a simple metal frame creates a catastrophic ripple effect at the maritime ports. How does that even happen?
Well, this ties directly back to our discussion on drayage. Picture a massive cargo ship arriving from Asia, stacked with 10,000 containers. The port cranes lift the containers off the deck, but there are no skeletal trailers available to place them on.
Oh, man.
Or maybe there are trailers, but no drayage drivers available to pull them out of the port.
So the container just sits on the asphalt.
Yes.
And the port physically runs out of space. The cargo ship can't unload the rest of its freight, so it anchors offshore, burning fuel and just waiting.
Which is incredibly costly.
And if the containers trapped on the dock are filled with seasonal inventory, like winter coats arriving in late November, they literally miss the retail window.
Wow.
Or, if they're filled with fresh agricultural produce, the goods literally rot inside the metal box.
Exactly. A shortage of skeletal trailers chokes the entire global supply chain.
And even if a logistics manager secures the trucks, the trailers, and the drivers, they still face the threat of labor disputes. The text mentions the vulnerability of the industry to wildcat strikes.
Yes. Unionized labor is deeply embedded in freight handling at ports and break bulk terminals.
Right.
While standard strikes are negotiated months in advance, wildcat strikes are sudden, unannounced labor disputes. A group of port workers or drivers simply walks off the job without warning.
And this industry is uniquely vulnerable to wildcat strikes because road transport has absolutely no storage buffer.
None.
Right. Unlike a massive warehouse that can hold extra inventory to ride out a storm, the trucks themselves are the moving storage.
Yeah.
So when the drivers walk off, the network instantly paralyzes. There's zero lead time.
Yeah, and navigating these hurdles requires relentless monitoring. Logistics managers utilize advanced transportation management systems to track variable costs and routing in real time.
Just to keep up.
And the legal compliance alone is a full-time job. The source notes that the Freight Transport Association publishes a massive annual yearbook of laws just for the European Union. A manager must maintain intimate familiarity with constantly changing emission standards, weight limits, and axle regulations for every single country a truck crosses.
It is so much more complicated than it looks. Let's kind of zoom out and review the physical foundation we've just unpacked here. We examined the literal ground, from standard highways causing unintentional bottlenecks to extreme wet roads demanding engine snorkel.
It's a truck submarines.
Right. We explored how infrastructure dictates the specialized vehicles, from Australian road trains to those crucial skeletal trailers. We broke down the connecting flight choreography of LTL shipping, the massive variable costs of diesel fuel, and the looming crisis of a 160,000 driver shortage. Every physical object around you right now likely took a ride on this incredible, complex, highly fragile road network.
It's true. And, as the industry stares down that massive shortage of human drivers and strict hours of service regulations, the text briefly mentions a detail that requires deeper consideration.
Oh, what's that?
To solve the driver and trailer bottlenecks at the ports, some facilities are heavily investing in autonomous technology.
Like self-driving trucks.
Yes. They are testing unmanned aerial vehicles and self-driving chassis to execute that initial drayage movement without a human in the cab at all.
Wow. Which leaves us with this final thought. We spent this deep dive establishing that trucking operates on a model of low fixed costs and extremely high variable costs,
Yeah.
right? burning fuel and paying hourly driver wages.
Right.
But autonomous trucks will completely flip that economic model on its head. In the near future, trucking companies will trade those high variable driver wages for massive fixed costs, basically purchasing fleets of million-dollar AI-driven rigs that never have to pull over to sleep.
It's a total paradigm shift.
It really is. Will the critical first mile of our global supply chains be entirely ruled by machines? It is definitely something to think about the next time you see a delivery truck idling on your street. Thank you for joining us on this deep dive. Keep asking questions, keep exploring, and we'll see you next time.